factoring. Before we jump into factoring the actual quadratics, which is going to be the focus of this video, let's look at a number, say 10. 10 can be broken down into the product of two other numbers, say 5 and 2, for example. There are others, like 10 and 1, or -5 and -2, but 5 and 2 we consider the factors of 10. So breaking down 10 into the product of two smaller values is the same concept that we are going to apply to a quadratic expression or equation. So let's keep that in mind for the factoring process. Our goal is to break down the expression into two or more, or I should say into the product of two or more terms of lesser degree. Now, quadratics. We've discussed standard form. The degree of this quadratic is 2, okay, which makes it, or which gives it its name of a quadratic equation. So degree 2 equations are quadratics. We are going to factor these to serve two purposes. So the use of factoring for us is going to be, 1, to simplify expressions. This will become more evident later in the course. And the other purpose is to solve these quadratic equations. What we need to note about the solving process, which is going to be what we'll spend most of our time doing, the solving, it's important that we take care of these prerequisite conditions. So these things must be satisfied prior to doing the actual factorization process. The first prerequisite that you need to take care of is set the equation equal to 0. And then next, put the expression in standard form. Okay, so make sure that standard form, you'll notice that it's in descending order according to degree. So the first term is degree 2, then we have degree 1, and the last one's degree 0, technically. Okay, so make sure it's the squared, the linear, and then the constant term in descending order. And you'll see why that's important when we go through the actual algorithmic process to factor quadratics. Now, we've established the use of factoring. We are going to look at two different cases and how to handle each one. The first case is if you are presented with a quadratic binomial without the C term. So what does that look like? When you see the term binomial, that means there are two terms in the expression. You'll notice a standard form equation had 3 terms. Quadratic, well, we're dealing with quadratic equations. So what does it mean to not have the C term? That constant at the end will not be there. So it'll look something like ax squared plus bx. So now, how do we handle this? In the event that we're solving, what's the difference between simplification and solving? Nothing except the solving requires one additional step. So just keep in mind, I'm going to focus on solving, and I'll actually tell you where the simplification occurs, where that would stop. But the solving process requires one additional step, so it's not worth going over each one. It'll basically be a redundant step-by-step process. So how do you handle factoring a quadratic binomial where there's no C term? First thing, take care of those prerequisite conditions. So the prereq, again, a reminder, set the equation equal to 0, put it in standard form. Second, factor out a GCF. The GCF, and I'll write it out, is the greatest common factor between the terms. So when you hear me reference GCF, a term you're probably familiar with, I'm saying take out the greatest common factor. So I'm going to do a side-by-side example. Let's say we had 3x squared equals negative 12x. The first thing I would want to do is take care of the prerequisites. So my step one would be set the equation equal to 0 and make sure the exponents are in descending order. So to fulfill step one, I add 12x to both sides. There you go. That takes care of step one. Step two is requiring us to take out a GCF. What does that look like? When you take out a GCF with algebraic expressions, you look at the numbers in each term first. So what is the largest number that goes into both 3 and 12? And you should be able to see that it is 3. So I'm taking out a 3. You must also look at the variable portion of each term. I have x squared in the first term and x in the second term. I'm asking myself, what is the largest variable that would go into both, or which each term is evenly divisible by? And the largest one is x. Now the question is, I pull out a 3x, and again, this represents the GCF. What is left behind is what happens when I divide both of the terms by the GCF. So off to the side, we had 3x squared plus 12x. I'm taking out a 3x from both. So what's left over? Well, 3 divided by 3 is 1. X squared divided by x is x. 12 divided by 3 is 4. X divided by x is 1. So times 1, I don't need to write it. So what's left over after removing the GCF is x plus 4. This left side of the equation, this is considered the factored form of that original standard form piece. And that is the simplification process through factoring. So what I have currently on the left side is the simplification through factoring of that original expression that was in standard form. Now, what is the additional step from that simplification process to solve it? What we have here is a product of two terms, which I said we would do when we're doing factoring. So I've broken down the standard form equation into the product of two terms. If the product of two terms equals 0, then it has to be true that either one or both of those terms needs to equal 0. So due to the possibility that either one could be equal to 0, we set each term equal to 0 and solve to get the solutions to the quadratic function. What we utilized is called the zero product property. So that is our third step here. Once you have it factored, you're going to use zero product property to set each term. This is important. Every single term, you don't get to choose, do every single one because you have to consider the possibility that any of them could be 0, equal to 0. Then solve each sub-equation to get the solutions to the quadratic. Now remember, when you're solving an equation, you're looking for values of x that would make that equation true. So when we looked at that original equation here that we were given, we're looking for values of x that would make 3x squared equal to negative 12x. We've found through the factoring process that if x were 0, that equation would be true. And you can see if you plug in 0 for x, that original equation would be 0 equals 0. Confirmed. If x equaled negative 4, well, negative 4 squared is 16 times 3 is 48. So I'd get a 48 on this left side if I plugged in negative 4. If I plug in negative 4 on the right side, negative 12 times negative 4 is also positive 48. Well, 48 equals 48. So negative 4 also makes the equation true. So that is our goal when solving. We're trying to determine values of x that make the equation true. So that is how you handle a quadratic binomial without a c term. You're going to set it equal to 0, take care of those prereqs. Then you're going to factor out a GCF. Okay, that's the big one. This is the difference between what we're going to do next. Okay, this is the main difference. It's the GCF thing. Okay, that's how you handle that. So case 2, this one is a little more involved. Case 2 is if you have a quadratic with a c term. Now, the quadratic could be either a binomial or a trinomial. So it could be 2 terms or 3 terms. So we'll make a note of that. Could be binomial. If it's binomial, it'll look like ax squared plus c. So it'll be missing the bx. The reason it's the bx term that has to be missing, because if the ax squared term was missing, we wouldn't have a quadratic anymore. Right, it's that degree 2 that defines the quadratic. I don't know why this isn't letting me write plus. Or it could be a trinomial. So tri means 3. 3 terms will have something that looks like a standard form equation. So no matter if it looks like a binomial or a trinomial with a c term, the convenience of this method is it actually doesn't matter which one you're faced with. So anytime you see a c term with a quadratic, you're going to handle it in the following way. Step 1, take care of the prerequisites. Step 2. So here's where things would help to have a side-by-side. So let's add that in. So I've added in this quadratic example to the left in red. Step 1, take care of the prerequisite conditions that need to be met before I actually do the factoring process. That would include me moving this thing all to one side of the equation, so it's set equal to 0. So I'm going to move the 5x and the 2 to the other side. I prefer to have a positive number in front of the squared term. So that's a preference thing. So prefer a positive coefficient for a. So for our a value in standard form, I prefer it to be positive. Step 2, here's the big one. Here's what you do. You're going to multiply a and c. That's step 2. So off to the side, we're going to multiply a and c. So a times c, a is positive 2, c is positive 2. So the product of a times c is equal to 4. Next, you are going to determine the factor pairs of the product of a and c that add up to b. So determine the factor pair for the product found in step 2 that adds up to b. So I'm going to break down 4 into factor pairings. So 4 could be expressed through the product of 1 and 4, 2 and 2. Now, neither of those add up to -5, but what we should remember is that I could get 4 by doing -4 and -1, or -2 and -2. And that's all the possible factor pairings. So of those 4 pairings, which pairing would add up to the b value of -5? It would be this pairing of -4 and -1. Once that has been determined, you're going to split the middle linear term. So you're going to split the b value, or that linear term, also referred to as the middle term when we're in standard form, into 2 parts, or 2 terms, with coefficients that are the pairing found in step 3. So what does that look like? So first off, the A times C was step 2. The selection of the pairing was step 3. So now we're on to step 4, which requires us to split the middle term. Don't forget to add on these x's to the middle. So don't just break it up into -4 and -1. If you want to highlight that, we're splitting that middle term. Keep that x variable with the split, and notice that the coefficients are the pairing that we found in step 3. Now, it doesn't matter which one you do first. So I could have done -1 or -2. So the order doesn't matter. So I'll even add that in here. Now, once you've done that, step 5 is factor by grouping. Now the question is, what is grouping? Well, we are going to group the first 2 terms and the last 2 terms. What you're going to do is remove a GCF from each group. The GCF from the first group. Again, look at the numbers. The largest number that goes to 2 and 4 is 2. Then look at the variables. Largest variable that goes into x squared and x is just x. What's left over is what happens if you divided both terms by that GCF. 2x squared divided by 2x is just x. 4x, or -4x I should say, divided by 2x is -2. Next, when you take out the GCF of the second pair, or the second grouping, it needs to leave behind the same thing in the parentheses that you had in the first group. So in order to get x minus 2 left over in my parentheses, I need to remove a -1 from that second group. Dividing each term by -1, -1x divided by -1 gets me positive x, that's where that comes from, and then positive 2 divided by -1 gets me the -2. Okay? The reason that's important, so this is step 5 here that we just completed, is now there's technically 2 terms here in a more larger sense. I have this whole thing and this whole thing. Both of those things have an x minus 2. So I can take out an x minus 2, and what's left over after I remove the x minus 2 from those 2 terms is what was in front of both of those 2 terms, which is 2x minus 1. Now, what does this do for us? First, this here is the factored form of our original equation, 2x squared minus 5x plus 2. That is the factored form. We broke down that quadratic into a product of two lesser degree terms. The quadratic is degree 2. You'll notice that each term in here is of degree 1. But also, what does this do for us in terms of solving? Well, again, I have the product of two things equaling 0. And by zero product property, if I have two things that are multiplied together that equal 0, it is possible that either one or both of them could be 0 in order for that to happen. So I set both terms equal to 0 and solve each term to find the solutions to the quadratic. 2 1/2. So let's finish our algorithm here. Factor by grouping. Once you've factored by grouping, you're going to use the zero product property to solve the sub-equations. For the solutions to the quadratic. So there's your step-by-step. I'm going to do a couple more examples if you need to see some others. In fact, I recommend that you look at these examples. So let's do two more. Let's say I had the equation x squared minus 8x plus 12 equals 0. All right, so I'm going to factor this. You're going to notice there's a c term, which means I'm going to have to, that's going to fall into that second case. So that second case, if we're solving a quadratic, make sure it's set equal to 0, make sure it's in standard form. That's already taken care of for me. Following the rules of factoring, we're going to do a times c, so it's 1 times 12. Then I'm going to write factor pairs of 12. So to get a positive 12, I can do positive 1, positive 12, or negative 1, negative 12. That's why those negatives are there. We need to figure out what pairing adds up to the b term. And you should see that it's negative 2, negative 6. Once you've determined that, you're going to split the middle term so that the coefficients of the split reflect that pairing. Once we've split it, we're going to group. Group the first two terms, group the last two terms. Take out a GCF out of the first two. I'm going to take out an x. That's the largest thing that goes into both. What's left over is what happens if I divided both those terms by x. We get x minus 2. When I look at the second two terms, I need to remove a GCF that would allow for the remainder in the parentheses to be the same as what I have in the first set. So what do I have to take out to get an x minus 2? You're going to have to take out a negative 6. You'll see that the signs are currently minus plus, but we want a plus minus inside that parenthesis. I take out a negative 6. What happens when you divide both those terms by negative 6? I get positive x and then negative 2. So my parentheses match, and that's important. You want your parentheses to match, and I'll actually add that in to that process on the first slide. Next, both of these terms have x minus 2. So I take out an x minus 2. What's left over is what was in front of each one. Solve each one through zero product property. If both of those things multiplied together equal 0, then either or both equal 0, and our solutions when we solve x equals 2, x equals 6. Now there's a shortcut that pops up with quadratic trinomials, or just quadratics that have an a value of 1. So we can add that in. Shortcut with a equals 1. You just ask yourself, what adds to C, sorry, what multiplies to C adds to B. That's the question you're going to ask yourself. So my C term was 12. So what multiplies to 12 adds to negative 8. You can do that whole process again. But once you figure out the pairing, you'll notice that when we finish the factoring by grouping, in this step, notice that what was in the parentheses when I got down to the factored form was that actual pairing that we started with. And that's the shortcut. So I know it's just going to be x minus, in this case 2, x minus 6. So you just add it in right there and you're good to go. You don't even have to go through the factoring by grouping process. That's the shortcut. So if you're still unsure of what I mean by that, let's say we have x squared plus 4x plus 4. And we want to factor this. So this isn't a solving one. We're just going to simplify. You should notice there's an a value of 1. So I'm just saying, all right, what multiplies to c adds up to b. So what multiplies to positive 4 adds to positive 4. And through some thought, you should have positive 2, positive 2. And I don't have to go through the split the middle if you feel comfortable with just jumping right to this. Because that's what you're going to get. Sorry, it's not a solving one. And this is the factored form, and you're done. Okay? If you had to solve it, you would break it down into 2 sub-equations and solve those. But shortcut when a is equal to 1. If a is not equal to 1, you have to use that grouping technique or that split the middle technique that is shown there. Okay, so that's a shortcut if you want to try. So before we do the next example, let's add that back into the grouping if I didn't already. So when you do factor by grouping, make sure you have the same thing in the parentheses. So parentheses match. So make sure those parentheses match when you do that, step 5. Then last one. Let's go back to something like this. 9x squared equals 1. So take care of the preconditions. That negative 1's the c term. So you'll notice that a is not equal to 1 here, so we can't use that shortcut. So I'm going to do a times c, which is negative 9. Now, we have to ask ourselves what multiplies to negative 9 but adds to the b term. Well, there is no b term. So that means what adds up to 0. So I'm looking for 2 numbers that multiply to negative 9 and add to 0. And with some thought, you should find out that it's 3 and negative 3. So we're going to split that 0 term. So originally, we can think of it like this. You don't have to actually write this. But you can think of it like that, and then splitting the middle into 3x and negative 3x, which is what we want to do. So we split the middle. Now we're going to use grouping. So group the first 2, group the last 2. Take a GCF out of the first 2. You'll see it's 3x. What's left over is 3x minus 1. What do I have to take out of 3x minus 1 in the second group so that I'm left over with the same thing in the parentheses? You have to take out just a positive 1 so that the same thing is there. Now, both terms have a 3x minus 1. So if we remove 3x minus 1, what's left over is what was in front of each parenthesis, which is 3x plus 1. I have a product now that equals 0. So I have a product of 2 things equaling 0. So one or both has to equal 0 for that to be true. Solve each one. Okay. Now, there is a shortcut to this type of problem as well. This problem, when we got to this part here, is what we call the difference of squares. The difference of squares is what happens when you have a quadratic where it's a perfect square minus a perfect square. Hence the term difference. So the operation has to be subtraction. If you add a plus in between, unfortunately you can't do this. All right, so how do we handle it? If you have a difference of squares, so if you see something in the form ax squared minus b, okay, where both of these terms are perfect squares, the factorization, the shortcut, is you do the square root of the first term and the square root of the first term in each one. So whatever the square root of ax squared is, that's what you put in here. So square root of the first term is the first thing in each parenthesis. The square root of the second term is the second piece in each parenthesis. And what's the operation that's in between? Every time it's plus minus, okay, or minus plus. All right, so for example, if you had x squared minus 4 and you had to factor that, x squared is a perfect square. 4 is a perfect square. There's a subtraction sign in between. So the shortcut, without having to go through that split the middle technique, whenever I have a difference of two squares, the square root of the first term is what goes in front of each parenthesis. Square root of x squared is x. Square root of the second term is what goes at the back end of each parenthesis. Square root of 4 is 2. Plus minus. Done. Okay, there's your factored form. One other example. Let's say we have 16x squared minus 1. Or sorry, let's do 25. Perfect square. Perfect square. Okay. The number in front matters when considering the perfect square. So 16 is a perfect square. If that was a 12 out in front, we wouldn't be able to do this. So I recognize a difference of two squares. The first term in each is the square root of the first term. The square root of 16 is 4. The square root of x squared is x. So it's 4x in front of both. The square root of 25 gets me what's in the back end of each parenthesis. And then minus plus or plus minus, as long as you do different signs in each. There you go. There's the factored form using the shortcut when I recognize a difference of two squares. So that is a video on factoring. You're going to be faced with two scenarios. You either have the quadratic binomial where there's no C term, or you do have a C term. If you do have a C term, you use that split the middle technique. Within the split the middle technique, I showed you two shortcuts depending on what you're presented with initially. If you have an A value equal to 1, you can do the shortcut. If you have a difference of two squares, you can use that shortcut. So why don't you take note of that, or look for those things, so you don't have to go through the whole process of splitting the middle like we did over on this left side when we went through that whole thing. Okay? Because I could have jumped from this starting point here of 9x squared minus 1 all the way down to this line right off the bat if I were to recognize that it was a difference of squares, right? So I could take out those 3 intermediate steps, which saves me some time, and it's a more efficient process. Now, the last thing I would like to note is that not all quadratics can be factored. If we can factor them, they present a very nice method or pathway to the solutions. Okay? So quadratics that can be factored, very nice pathway to the solutions. In the event that they're not factorable, we're going to learn other techniques, but just keep in mind that you can't factor everything. That is important to know. And that is where I will end the factoring video.